In order to really understand the physical layer, you need to understand how the communication takes place in the first place. The physical layer defines the electrical, the procedural, and the functional specifications for a physical link. So what's a physical link? Well, it's either electrical or it's by light. In some of the newer network connectors, we use light. We use light pulses and light frequencies. In the older networking, we use electrical. We use electrical pulses, and either the fluctuation of current happens during a timing signal or it doesn't happen during a timing signal, and that produces the zeros and ones. So the physical layer defines how all of these zeros and ones are going to be produced and how they're going to be interpreted. Those are called bits. So at the physical layer, you'd see things like voltage levels, or timing and voltage changes, or physical data rates, whether that's light or whether that's electricity. You also might see maximum transmission distances. Like, for example, with Ethernet, with twisted pair cable, it's understood that we can only go 100 meters without using repeaters. We'll talk more about these kind of things later on, but all of those are defined at the physical layer. Physical connectors, the different types of connectors that we use. Of course, we would use totally different kind of connectors for twisted pair cable than we would for coaxial cable, than we would for fiber optic cable. We'd also use different types of connectors to connect the network interface card itself to the bus inside the computer. In other words, the physical layer would determine that it had a certain number of pins or that it runs on a certain voltage. Take a look at cables. It would determine how, for example, in a Cat5, Category 5 cable, it would determine how many twists there are per foot of Category 5 cable. So the physical layer defines all of those physical characteristics of components, of network components, and it defines how those physical characteristics will allow those components just to be able to keep up with zeros and ones, with fluctuations in current. And the physical layer is at the bottom of the OSI model. It's layer 1. So all of these layers work together. The message starts at the top, starts at the application layer, and then works its way down through all of the layers of the OSI model that we've discussed, and then goes through the wire in its physical sense, or through the wireless network, or through the fiber optic medium. We're just calling that, we're using that in a broad sense as to going through the wire. And then on the other side, it comes up the other way. So the other side receives it as physical, and then moves it up to data link, and on up to network, and on up through the network. So this is how the process of communication works. But how does the process of communication work in regards to having lots and lots of different computers on a network at the same time? In other words, when you have multiple computers on a network and they all want to send information, how do we control all that flow of information? Well, we do that by using different components that work at different layers of the OSI model. So now that we understand a little bit about the OSI model, in our next chapter we're going to take a look at how we start to implement some of these things. Specifically, we're going to look at collision domains versus broadcast domains. That's next.